Hey everybody, it's Mr. P, and what I'd like to do is go through some example problems for 10.2 Part 2, which would be simplifying square roots when we have fractions. So this would be your e-learning for Wednesday, April 15th. Remember Part 1 from last week, okay, from Wednesday of last week was simplifying square roots and multiplying square roots and simplifying. Today again is going to be simplifying square roots when we have fractions or when we're dividing. So we're going to go through a few examples. So let's start with a couple here. So let's start with the square root 25 over 36. So what we should notice about 25 and 36 is that those are perfect squares, first of all. Another thing we want to notice, or what we another way we can write it is that when I have a square root of a fraction, I can write that as the square root of the numerator over the square root of the denominator. So square root of 25 over square root of 36. We know square root of 25 is 5, right? Square root of 36 is 6. So my answer there would be 5 over 6, or 5/6. And we want to keep those as fractions. Okay. I have another one here. Square root of 10 over square root of 49. Let's rewrite that. Square root of 10 over square root of 49. The denominator, I should recognize 49 as a perfect square. Again, perfect square is when I take a square root, I get a whole number. Right? So square root of 49 is 7. So I'd have square root of 10 over 7. Okay, so, and square root of 10 would be my numerator, and then 7 would be my denominator. All right, let's look at a couple more. Okay, so let's say I have square root of, say, 40x to the third on top and 25 on the bottom. So first of all, let us go ahead and rewrite it. So 40x to the third, square root of that on top, square root of 25 on the bottom. Okay, so one thing we can do right away, square root of 25, that's a perfect square, so that simplifies to 5. So square root of 40x to the third over 5. Then what I want to do is rewrite the numerator, so it's square root of 40, and x to the third, what I want to do is separate that into x, square root of x squared, and square root of x, because as you had seen in the last part of the section, x squared times x, right, that's equivalent to x to the third. When we multiply square roots, we multiply what's inside. Remember, when we multiply exponents, remember our laws of exponents, x squared times x to the first, x squared times x, 2 plus 1, so that gives us 3. We can separate it out, okay? And square root of x squared just happens to be x, and then I just have a square root of x here. Square root of 40, remember we look for a perfect square that goes into 40. The biggest perfect square that goes into 40, and that happens to be 4. So we can separate this out into square root of 4. 40 divided by 4, remember we're basically factoring it, would be 10. Okay, so that's square root of 4, square root of 10, I have x, and I have square root of x. So let's simplify that a bit. So square root of 4, what's that? That is 2. Square root of 10 and square root of x, I can multiply those back together because they're I can multiply square roots and I get the square root of the product of the two, or however many terms are inside. So I can rewrite this as 2. Square root of 10 times square root of x is square root of 10x, and then I'm just also left with an x, so I can just throw the x in front here. So 2x, square root of 10x, and then on the bottom, I'd be left with 5, okay? So again, split it up in the square root of numerator, square root of denominator. Okay, square root of 25 is 5. We separated out the top. Okay, square root of 40, square root of x squared, square root of x. Again, we were able to separate out x to the third into x squared and x. Square root of 40, remember, we factor out the biggest perfect square. Square root of 4, square root of 10 is what it would factor into. Square root of 4 is 2. I multiplied the square root of 10 and the square root of x back together, so it's just square root of 10x. And of course, I just had an x left over here that I have to have as part of my answer, and then 5. All right. So let's go ahead and look at another one. So again, this would be your final answer. Okay. So our next example. Let's go ahead and clear the board here. So what if we have 4 divided by the square root of, let's say, 13. Okay, so one thing that we want to know about our answers is that our answers should never have, our final answers should never have a square root or any kind of radical in the denominator. So if there's a square root in the denominator, what I need to do is what I call rationalizing the denominator. So basically, multiplying the denominator by something that's going to cancel out the square root. Okay, so my final answer does not have a square root in the denominator. So if I have square root of 13, in order to cancel that out, what I would do is multiply the top and bottom by square root of 13. Okay, why? Because square root of 13 times square root of 13 is 13. Just think about it. Because square root of 13 times square root of 13 is actually square root of 169. Because I multiply the two terms inside, the square root of 69 is 13. So multiplying by the square root of 13 there on the bottom is going to leave me with 13. On the top, I will have 4 times the square root of 13. Now, looking at just, the numbers that are here, if I can reduce the fraction, I'd want to reduce it, but 4 over 13, that doesn't reduce anymore. So my final answer would be 4 times the square root of 13 over 13. Again, this is called rationalizing the denominator, making the denominator so it does not have a square root in it. Okay, so remember the square root, basically what we have is a square root squared. Okay, taking a square root squared gives you what's inside the square root. So square root of 13 times square root of 13, or the square root of 13 squared, cancels out the square root and leaves us with 13. Okay, the same would be true, let's say we had 5 over square root of 15, for example, right? You do the same thing. Multiply numerator and denominator by square root of 15. Bottom would end up being 15. Top would be 5 square root of 15. And then over 15, that would actually reduce. 5 over 15 is 1/3, so you just have square root of 15 over 3. But again, just a couple examples there of how we get rid of a square root in the denominator. Okay? Let's look at another one here. So, let's say I have big square root. Let's say I have 54, I have 6, so let's say I have 54 x to the 16th, and then y to the 8th on top, and I have 6x to the 12th, and y to the 10th on the bottom. I'm taking the square root of all that. And you're like, okay, there's a lot of terms there. What do we do? Well, let's take it one step at a time. Before we even worry about taking the square root, what we can do is reduce what's inside the square root. So, first of all, 54 over 6, I know that is 9. Okay? X to the 16th divided by x to the 12th, so they have the same base of x. Remember, when we divide with exponents with the same base, we subtract. So 16 minus 12 would give us x to the 4th. Y to the 8th over y to the 10th Okay, that gives us, when we subtract, right, y to the 8 over y to the 10th, that gives us y to the negative second. Remember, we subtract, remember, if we remember our laws of exponents, it's the same thing as 1 over y to the second, which would mean y to the second would go down in the denominator, okay? Now, simplifying, okay, let's kind of break it up here. So, basically what we have on top is square root of 9, square root of x to the 4th. Okay, on the bottom, I got square root of y squared. So, what we know, square root of 9 happens to be 3. And really, square root of x to the 4th is square root of, we can think of it as square root of x squared, square root of x squared. Okay, if we want to break that down a little more. Square root of y squared on the bottom is just going to be y. Okay, because the square root of something squared is just itself. But square root of x squared, that happens to be x. So I have 3x. Square root of x squared again is x. So 3 times x over y. And I can simplify that. What's x times x, right? Think of x to the first times x to the first, multiplying exponents, terms with exponents with the same base. We add 1 plus 1 is 2. So 3x squared, or 3x to the second, over y would be our final answer. Okay? So just see what you can simplify in a problem like this. 54 over 6, hey, I know that's 9. X to the 16th over x to the 12th. Okay, x to the 4th. Y to the 8th over y to the 10th. That's y to the negative 2, or 1 over y squared. Then I'm down to something like this. Then I break everything up into individual square roots. Okay? So 3x squared over y would be your answer to that problem. Let's look at one more. All right? And you will have problems very similar to this in your assignment, okay, for April 15th for the e-learning on Schoology. The last one, let's say I have 6 times the square root of 48, and on the bottom I have square root of 32. Okay, so what am I going to do here? So first of all, you're saying, you know, we can't have a square root in the denominator. That is true. Okay, but what I want to do is actually simplify both the numerator and denominator, right, by finding perfect squares to factor out and simplifying the square roots, so then we can see if it's going to make it easier for us to simplify. So we have 6, then we look at 48. Okay, and we think of what is the biggest square root that goes into 48, or biggest perfect square that goes into 48. Remember, our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, so on and so forth. So we just find the biggest perfect square that goes into 48 is 16. So square root of 16, how many times does 16 go into 48? The answer is 3, so we split that up into square root of 16, square root of 3. On the bottom, all right, what you're going to have is square root of 32. Okay, what's the biggest square root that goes into 32? The biggest perfect square, I'm sorry, that goes into 32 is 16. So square root of 16. And how many times does 16 go into 32? Twice. All right. So actually what we can see here is square root of 16 and square root of 16. We can just get rid of that. So I have 6 square root of 3 and square root of 2 on the bottom. Okay. And so question is, am I done? Is that my final answer? Well, let's look at the denominator. There's a square root of the denominator. Can we have square roots in the denominator for our answer? No. Okay, how do we get rid of it? Think back to one of our previous examples. So since there's a square root of 2 here, to cancel out the square root, I'm going to multiply the top and the bottom by the square root of 2. Okay, so on the bottom, remember square root of 2 times square root of 2, right? That gives us square root of 4, which is just 2. So the denominator is 2. Square root of 3, remember we have the 6 still, but square root of 3 times square root of 2. Since they're both square roots, we can multiply what's inside. So 3 times 2 would give us 6 square root of 6 over 2. And what we'll notice here is that we can simplify even more because 6 divided by 2 is 3. So I would just have 3 square root of 6 as my final answer. Okay. So again, what we did here, we did rationalizing the denominator, which means we got rid of the square root in the denominator. Okay. So yes, let's go ahead and again recap what we did for that problem. So first of all, we simplified our square roots. We were able to cancel out square root of 16 and square root of 16. Okay, remember when we simplify square roots, we factor out perfect squares, like again the biggest perfect square that goes into 16, and then it went in 3 times to 48. Biggest perfect square here was 16, went into 32 twice. And then of course we ended up with square root of 2 in the denominator here. So we had to multiply top and bottom by square root of 2. And then we ended up with 3 square root of 6 because 6 over 2 was 3. Alright, let's go ahead and try one more here. So let's say we got, so it's a very similar problem to the last one. 3 square root of 64 over square root of, let's say, 128. Alright? So, I look at the square root of 64. What can I see about the square root of 64 right away? 64 is a perfect square. So that's going to help us out, because right away, I can have 3 times 6 square root of 64, which is 8. So 3 times 8 over square root of 128, which is then going to be 24 over square root of 128. Of course, we're not done yet because we have a square root in the denominator, but let's make this a little easier to deal with. So rather than multiplying by square root of 28 top and bottom, let's simplify first. So square root of 128, we're thinking what is the largest perfect square that goes into 128? Okay, and we should find that that is 64. So square root of 64, how many times is 64 going to 128? That's 2. So square root of 64, square root of 2. Let's simplify that. So 24, we know square root of 64 is 8, correct? So that's 8, and then I got square root of 2. Okay, we're still not done because we still have a square root in the denominator. So what do we need to do? Multiply the top and bottom by square root of 2. So on top, I just have 24 square root of 2. On the bottom, I have 8 times square root of 2 times square root of 2, which is just 8 times 2, which we're going to see is 16. So 24 square root of 2 over 16. And we can simplify that a little more. See, 8 goes into 24 3 times, into 16 2 times. So I would have a final answer of 3 square root of 2 over 2. That would be my final simplified answer. Okay? So again, on the bottom here we have square root of 2 times square root of 2, which was just 2. Okay, then I took 8 times 2, which was 16. 24 over 16 is a fraction that can be simplified, so 3 over 2, so 3 square root of 2 over 2 would be your final answer. Remember, you do not want fractions or radicals or square roots in the denominator. Okay, so this is Mr. Pete signing off until next time.